How's it going? This video is meant to help you out with this Jamboard that we're starting today. Our next unit is going to be about polynomial functions and rational functions. So I'm going to show you some stuff that is a bit of review. That way we can be prepared as we start our unit. First thing we need to be proficient with is multiplying polynomial expressions. We've learned in the past that polynomial functions can be written in two different forms, factored form and standard form. Factored form can be written something like this. I've given random variables, or random parameters rather, a, b, c, d, e, and f. And we can see that a factored form polynomial can be written as the product of three linear factors, most of the time. Sometimes not necessarily all linear, but they can be written as the product of factors. A standard form polynomial is the sum of multiple terms. So it's separated by addition, or if one of these values happens to be negative, these could be subtraction. But still, it's technically the sum of multiple terms. It's going to be important to convert between forms. This video is going to show us how to convert from factored form to standard form. So when we have a polynomial in factored form, we can rewrite it in standard form by multiplying the factors together. It's important that we can only multiply two factors together at a time. So let's look at this example. Let's let f be a function defined by f of x equals x plus 6 times x minus 2 squared. And we're going to write an expression for f of x in standard form. Right, firstly, I know that I can basically take this x minus 2 squared and write it times itself 2 times. So we can rewrite our expression right away as f of x equals x plus 6 x minus 2 and x minus 2. Would have two repeated factors of x minus 2. All right, and now we can multiply two factors together. Doesn't matter which two we do first. I could do x plus 6 and x minus 2. I could do x minus 2 and x minus 2. Your choice. I'm going to do these two factors together first. To do this, we've learned how to use diagrams in the past. These diagrams I've called area models. You might have seen them before. You might have heard them called something different. So to build a diagram, we're going to use this tool over here. It allows us to build a little box. I'm going to split it up into equal sections. Up on the top, I know that I'm going to have x and 6. So positive 6, I'll just write x and 6. My other factor was x and minus 2. So on the side, I'll have x and minus 2. And then I'm going to split this box up into, well, I have 2 columns and 2 rows. To make a straight line, I'll hold shift while I'm drawing, and it makes a straight line. If I don't hold shift, it's like all crooked and ugly. So I'm holding shift. Now we just multiply to get what goes inside, like area. The area of this box would be its length times its width, x times x. Hence why we call it an area model diagram. So that's x squared. Now we'll go 6 times x, that gets us 6x. X times negative 2 gives us negative 2x. And 6 times negative 2 is negative 12. And we have just uncovered our product. To get that, we'll see that it's the sum of all of the terms here. Unfortunately, I can't add x squared with the others because it's not a like term. So I got to look for like terms. I see 6x and 2x are like terms. They have the same variable and the same exponent. Technically, it's a 1. So I'll combine these together. These two combine to be 4x. When I add them together, 6x and negative 2x is 4x. Out of here, we just get this x squared. It was all alone, no like term. And out of here, we get negative 12. So that means that this next factor, f of x, will be equal to x squared plus 4x minus 12. X squared plus 4x minus 12. If If you don't want to use this symbol right here, you can leave a little space and you can handwrite the exponent, or you can type it in and just shrink it. And we have x squared plus 4x minus 12. Some Chromebooks will automatically make it an exponent though when you type, if you have it set up. And we still have this x minus 2 right here. We're not done. Now we have to multiply this quadratic factor by this linear factor. So I'll set up another diagram to do that. This one might need to be a little bit bigger. So along the top, I'll have x squared, 4x, and minus 12. You could flip the box sideways if you did x minus 2 along the top and x squared plus 4x minus 12 along the side. That is okay as well. And over here, I'll have x minus 2. Split this up into 3 columns and 2 rows. And we multiply again. X squared times x gives us x cubed. X squared times, or 4x times x gives us 4x squared. Negative 12 times x gives us negative 12x. And now my second row. X squared times negative 2 is negative 2x squared. 4x times negative 2 is negative 8x. And negative 12 times negative 2 is positive 24. And now I know that the product will be the sum of all of these sections. So we got to look for like terms. There's no like term with x cubed, so that just comes out. 4x squared and negative 2x squared are like terms. So this diagonal combines to be 2x squared. Negative 12x and negative 8x are like terms, so this diagonal combines to be negative 20x. And 24 doesn't have a like term, that's just a constant term. So this just comes out, and now we have our final answer. F of x equal to x cubed plus 2x squared minus 20x and plus 24. And we have now written it as the sum of different terms. So this is standard form. Hopefully this helps. Good luck.